In this video, the learner will determine the volume of pyramids and cones. Let's remind ourselves about the pieces of pyramids. So in the polyhedron version of the pyramid, remember the top point is called the apex or the vertex of the pyramid. From the vertex straight down to the center of the base is the height. Notice we cannot see that height from the net version. We would have to go from the center of the base straight outward, and we can't do that. So we don't see the height on this one over here. From the center of the base to the side, that's our apothem. Then connecting that height triangle from the apex to the middle of the base edge is the slant height. So again, we have that right triangle with our height being that vertical leg, the apothem being that horizontal leg, and then that slant height being the hypotenuse. Then when we draw our base shape, we also have the apothem illustrated in that. So we can use this to help us find area. In the net version, we have our base. We also have our lateral faces, which are the triangles. We have that lateral edge. And then from the vertex straight down to the middle of the side is your slant height represented on the net. Now let's talk about volume. Remember, volume is the amount of space inside a polyhedron, so it's how much we could pour into it and fill it to the top. I want to think for a second and connect this to a prism. So remember, the volume of a prism is the area of the base times the height. Well, if we were to take 3 pyramids of equal volume, so the green, red, and blue all have the same volume. This illustration shows if we bring those together, we actually form one three-dimensional figure. And we form that prism made up of those 3 pyramids. Which means for those 3 pyramids of equal volume, we have one prism. So this prism is actually 3 times the volume of one of those pyramids. So if we wanted to find the volume of just one of these pyramids, we could take 1/3 of the volume of this prism with the area of that red base and its height. And that's exactly where we get the formula 1/3 big B times H. So the volume of a prism is 1/3 area of the base times the height. Remember, as we go through these formulas, P is perimeter of the base, B is area of the base, H is height, and L is slant height. In this example, we're going to find the volume of the square pyramid. Notice we're given a base edge of 12 and a height of the pyramid of 8. We're going to be finding volume, so we're going to be using the formula 1/3 big B times H. I've drawn my height triangle and my base shape here, and I'm going to use those to help me find P, B, H, and L. So here I have a base edge of 12, which gives me a perimeter of 48 units. The apothem cuts that side in half, which also makes the apothem 6. I could find the area of the base by doing 1/2 apothem times perimeter. So 1/2 times 48 times 6 gives me 144 square units. I was given the height of 8, and I just need big B and H to find volume. So volume equals 1/3 times 144 times 8, which gives me a volume of 384 cubic units. We didn't need the slant height of 10 units, but we could have easily found it using our height triangle. We were given the height of 8, and we found the apothem of 6, and we could have done Pythagorean theorem to find that slant height of 10. In this example, we're going to find the volume of the regular triangular pyramid with a base edge of 32 root 3 and a slant height of 34. So I've got my formula of 1/3 big B times H, and I'm ready to find P, B, H, and L. I was given that my slant height is 34, so I know that's going to be the hypotenuse in my height triangle. I also know I had a base edge of 32 root 3. I'm going to use that to help me find my perimeter of 96 root 3. To find the area of my base shape, I'm going to use 1/2 apothem times perimeter. The apothem we have to find using that 30, 60, 90. The apothem cuts that 32 root 3 in half to get 16 root 3. That's across from the 60, which gives me across from the 30 of just 16. So my apothem is 16, and my perimeter is 96 root 3. So I have 1/2 times 16 times 96 root 3, which gives me the area of the base of 768 root 3 square centimeters. In order to find volume, I need to have the height of the pyramid. So I need to solve for this length in my height triangle. I know from my base shape that my apothem is 16, which is this horizontal base in my height triangle. So I use 16 and 34 in Pythagorean theorem to find the height, which will give me 16 squared plus x squared equals 34 squared. Solving Pythagorean theorem, we get that our height is 30. Now that we know the area of our base and the height of the pyramid, I can plug that into our volume formula. So I have 1/3 times 768 root 3 times 30, which gives me a volume of 7,680 square root of 3 cubic centimeters. I want you to find the volume of the regular triangular pyramid with a base edge of 20 root 3 and a height of 24 inches. Here we're finding the volume of a regular hexagonal pyramid that has a base edge of 6 and a slant height of 14. So I again have my formula, volume equals 1/3 big B times H. I was given a base edge of 6 and a slant height of 14. I labeled the 14 on my height triangle and the base edge of 6 on my base shape. Knowing that this is a regular hexagon, I know my perimeter is just 6 times 6 centimeters, which gives me 36 centimeters. To find the area of the base, I'm going to be using 1/2 apothem times perimeter. So I need to find that apothem. I'm going to be using my 30, 60, 90. I know that this half of the side is 3, so across from the 60 is going to be 3 root 3. So my apothem is 3 root 3. My perimeter I knew is 36. So 1/2 of 3 root 3 times 36 gives me 54 root 3. So big B, the area of my base, is 54 root 3. To find the height, I need to use my height triangle. I know from my base shape here that the horizontal base of this right triangle is 3 root 3. I need to solve for the height. Plug 3 root 3 and 14 into Pythagorean theorem and solve for that other leg. So 3 root 3 squared plus x squared equals 14 squared. Solving Pythagorean theorem, I get that my height is 13. And I already knew the slant height was 14 from what we were given. To find volume, I just need big B and h. So plugging that into the volume formula, I get 1/3 times 54 root 3 times 13. Multiplying everything but that root 3, I get 234 root 3 cubic centimeters. I want you to try this example using a base edge of 16 and a height of 13. Let's again remind ourselves the pieces of the cone. In the net, we have the lateral surface. We also have the circle, that's the base. Of that base, we have the radius. And along that lateral surface, we have our slant height. We can also see our slant height in the cone here. That's the measure along the slant. We have the vertex, which is the apex of the cone. And from the apex to the center of the base, we have the height. From the center to the edge of the circle, we have the radius again. Using the radius, the height, and the slant height, we again form that right triangle, this time with R, H, and L. For this cone, we're going to be finding the volume. The cone and the pyramid have the same formula for volume. It's going to be 1/3 big B times H. Big B this time is just the area of the circle. So I was given a radius of 15 and a slant height of 25. I first am going to find big B by finding the area of the circle. That's going to be pi r squared. So pi times 15 squared gives us 225 pi. I was given the radius of 15. I need to be able to find the height of my cone to be able to find the volume. I was given a slant height of 25, and I know my radius is 15, which is also this horizontal base of my height triangle. I can use Pythagorean theorem with 15 squared plus x squared equals 25 squared. The x will represent that height that I'm missing. Solving Pythagorean theorem, I find that x is equal to 20, which means the height of my cone is 20. So now I can plug in big B times h for the volume. So volume equals 225 pi times 20, which gives me 450 pi cubic units. I want you to find the volume of the cone with a radius of 7 and a height of 24.